let us discuss about service governance. In microservices world, there are so many microservices and they all need to be communicated. And we also know that the microservices need to have its own life cycle. So we need to provide a mechanism to govern the microservices. For example, the service governance deals with identifying service registration and service discovery. So what it means is that there are independent microservices, right? If we register each of the microservices in the registry, other microservice can identify which service can take up the next call or can serve its requirement. So we need to provide a service registration functionality and service discovery functionality. Services are independent, right? So there will have some anomalies. That means the behavior of them may be not as expected sometimes. For example, the performance may not be as expected, or a call to a service may fail. Maybe there is a problem with the network. So there are a lot of anomalies that we can expect in the microservices world. So since these are independent, we need to provide a mechanism to address these anomalies. So we need to notice them, we need to observe them. And the third thing the service governance deals with is overloaded with requests. The cases when a lot of requests, incoming requests are coming to a microservice, then it gets overloaded. That means the server will not be able to respond back as fast as we expect because of the lot of incoming requests. So what do we do in such cases is to do a load balancing, to do a traffic management. So we need to do it by using different techniques. For example, we can use an SDK to do this with these features, or we can also use a framework like Spring Cloud to do it. However, this the best way of doing this is to use a infrastructure solution rather than a software solution for this like SDK and framework, because this will tightly couple our application code with it. Now, by bringing in infrastructure to address these governance requirements, the developers can focus but on the business requirement that they're specialized to do. How it does is the there is a open source tool called Kubernetes which provides the orchestration of the microservices. Now let's see what it does. There is a service object which will have an IP address, and this IP address when invoked will call the service object. There can be multiple service objects within a cluster. So whenever a service is requested by this IP address, this service object will call this service internally. So by calling the name of the service also, we will be able to invoke the microservice, because Kubernetes can provide DNS service also. Like we know the DNS which maps the IP address with the name of the microservice. Similarly, in a cluster, we can invoke each of the microservices by its name. Like if it is a microservice for payment function, if it's a microservice for cart function, if it's a microservice for like function. So we'll be able to call all of them by their names. Behind the names, there will be IP addresses. Behind the IP addresses are like service objects, and these service objects are provided by Kubernetes. That's how Kubernetes will be able to provide as an orchestration. Also, kubeproxy can provide a load balancing concept. Like if there are, we can provide multiple instances of the microservice with the same service object, so that if more application requirement, I mean incoming requests are coming to the application, the load can be balanced across multiple copies of the microservices, which is also provided by Kubernetes.